Have you ever heard someone say, if the new version has a problem, just roll it back? It sounds so simple, right? Like hitting an undo button for your entire system. But if you've ever been in that situation, you know the truth. Rolling back is often a nightmare, and sometimes it fails spectacularly. Why? Because the idea that you can simply rewind time is an illusion. The world has already changed, and you can't just pretend it hasn't. Imagine this. You've deployed new code, and a critical bug is discovered. The immediate reaction is roll back, revert the commit. So you do. You switch the code back to the previous, stable version. But the chaos doesn't stop. In fact, it might even get worse. Users are still reporting errors, data is getting corrupted, and the whole system feels like it's tearing itself apart. You've reverted the code, but you haven't reverted reality. The core problem isn't just about the code. It is about the irreversible march of time and the permanent changes made to the world outside your codebase. Let's break this down. Your code is just a set of instructions. Reverting it is easy. It's like swapping out a recipe in a cookbook. But what about the cake that's already been baked using the wrong recipe? That's the real issue. In the software world, this cake is the state of your system. This includes data written to your databases, messages sent to processing queues, entries added to caches, or even emails sent to customers. When your buggy new code ran, even for a few minutes, it interacted with these external systems. It changed things. Rolling back the code doesn't magically unsend those emails, unwrite that database record, or pull a message back from a queue. The state of the universe has been altered, and your old code now has to exist in this new, slightly broken reality it wasn't designed for. This is the heart of the rollback dilemma. The code can go back, but time and state cannot. To make this crystal clear, let's use a metaphor. Think of your application as a massive logistics company. Your code is the engine in your delivery truck. The old engine was reliable, and the new engine you just installed is supposed to be faster and more fuel efficient. The data your application processes is the cargo, and your database is the central warehouse ledger, meticulously recording every package that comes in and goes out. Now you deploy the new engine, and trucks start making deliveries. But you quickly realize the new engine has a flaw. It's miscalculating routes and sending trucks to the wrong addresses. The solution seems obvious. Swap the new engine out and put the old one back in. That's the code rollback. But here's the catch. While you were figuring this out, trucks were already out on the road. Cargo has been delivered to the wrong places. The warehouse ledger has been updated with incorrect delivery records. You can put the old engine back in the truck, but that doesn't magically teleport the delivered packages back to the warehouse. It doesn't erase the incorrect entries in the ledger. The warehouse manager is now staring at a ledger that says a package is in City A, but the customer is calling furious. Because it ended up in City B, the old engine, now back in service, has to operate based on this corrupted ledger. It might try to dispatch a truck to pick up a package from a location where it never was, based on the bad data. The problem is no longer the engine. It's the state of the world, the location of the cargo, and the records in the ledger that has become inconsistent. That's why rolling back is so hard. You're not just changing an engine. You're trying to clean up a logistical mess where the record of what happened no longer matches reality. The database ledger cannot simply be rewound. So the fundamental challenge of a rollback is reconciling the reverted code with an altered external state. Your old code expects the world, specifically your data, to be in a certain format or state. It has assumptions. For example, it might expect a user's status to be active or inactive. But what if your new buggy code introduced a new status like pending underscore verification? When you roll back, the old code encounters this pending underscore verification status. It has no idea what to do with it. It's like a person who only speaks English suddenly seeing a word in German. They'll either crash, ignore it, or misinterpret it, leading to even more bugs and data corruption. This mismatch between the code's expectations and the data's actual state is where most rollbacks fail. You can't just turn back the clock on the data. You need a strategy to handle this new reality. This is why a simple code revert is rarely enough. You also need to perform what's called a data migration, or some kind of data cleanup, to make the state of the world compatible with the old code again. This gets even more complicated in modern distributed systems. Let's go back to our logistics company. What if you don't have just one central warehouse ledger? What if you have multiple warehouses and each one keeps its own local ledger, and they're all supposed to sync up with each other? Now, Imagine your buggy new engine causes one warehouse to record deliveries incorrectly. When you roll back the engine code, all the warehouses are now running the old software. But one of them has a ledger full of bad information. When the other warehouses try to sync with it, they get conflicting reports. Warehouse A says the package is in transit, but Warehouse B says it was delivered yesterday. Which one is the source of truth? How do you resolve this conflict without shutting down the entire operation? This is the daily nightmare of engineers working with distributed databases and microservices. When data is being written and changed in multiple places at once, determining the single source of truth becomes incredibly difficult. A rollback in this environment isn't just about fixing one ledger. It's about untangling a web of interconnected, inconsistent states, which is an order of magnitude harder. So let's recap. The simple idea of a rollback is a dangerous illusion. It's not an undo button. The true difficulty lies in the irreversibility of time and state. Your code can be reverted, but the data it wrote, the messages it sent, and the changes it made to the world are often permanent. The core challenge is making your old, reverted code function correctly in a new, altered reality that it was never designed to handle. And in distributed systems, this problem is amplified as you struggle to find the source of truth amidst a sea of potentially conflicting data. So how do we solve this? We can't just throw our hands up and say rollbacks are impossible. Instead, we have to plan for them. This involves strategies like making our database changes backward compatible, so old code can still read new data. It means using techniques like feature flags to test new code in isolation before it can affect the entire system. It also means designing our systems to be more resilient, perhaps by using event sourcing patterns that give us a perfect, replayable audit log of every change that ever happened. By embracing the complexity and planning for failure, we can turn the terrifying rollback scramble into a controlled, predictable process. It's not about fighting against the flow of time, but about building systems that can gracefully adapt when things inevitably go wrong. Thank you so much for watching. If you've ever been through a painful rollback, share your story in the comments below. And if you want to learn more about building robust software systems, don't forget to like this video and subscribe to the channel for more deep dives. See you in the next one.